All right, guys, so whenever I picked this project for us to do, this was my favorite page in the entire project, so get excited. So it says, your city is a bit too small for a zoo, so you opted for a petting zoo instead. Fill in the missing measurements on the drawings of the zoo below. Remember, the drawings are not perfectly to scale. Okay, so as you can see, there's some missing measurements on some of these areas, and we need to find area or perimeter if they ask us to. Different things, like there's different issues that are happening in different little areas in this petting zoo. So let's look at this top one. So this top one gives us the length of one of the sides, and it gives us the area, but it doesn't give us the width or the perimeter. So if they give us the area and they give us the length, well, let's write on a piece of paper, because you're going to work all this out on a sheet of paper for me, okay? So if we write down the formula for area, which is, let's focus a little bit, Miss Hargrove. Okay, so if we write down the formula for area, which is A equals length times width, well, I have the area, right? So I'm going to say that 160 feet, well, actually, let's just write the number, 160 equals, right, I'm just plugging in numbers here, equals 20 times W. Okay. All right, are you ready for this? I'm about to blow your mind. Are you ready? You're about to learn some pre-algebra here. So first of all, what's the inverse operation of multiplication? Because I need to find what that W is, and I don't know what I'm multiplying 20 by to get to 160. But what's the opposite of multiplication? Division. So do you think that if I have a whole and a part, and I'm trying to find the other part, that I could divide those two numbers and get what W is? I could. So W is going to equal 160 divided by 20. And I know what you're thinking, Miss Hargrove, we can't divide by two-digit numbers. We don't know how to do that. Well, guess what? You do know how to do that. Because we can just find a what? What do you see here? I see it. I see something. I see a hidden fact. I see something that's going to make my life a whole lot easier. I'm going to box that hidden fact right there, 16 divided by 2. Do you remember what 16 divided by 2 is? What is 16 divided by 2? If you need to count by 2s, count by 2s and see how many times you count by. 16 divided by 2 is 8. Then, if I have 1 0 on this side and 1 0 on this side, those cancel out, and I don't need to add any zeros to the end. So 160 divided by 20 is 8. So I'm going to fill that in right here, and then that will help me complete my area. My perimeter. All right? So you can go ahead and finish that one after we're done here. So let's look at a couple other ones. First of all, this pig pen over here is a regular hexagon, right? Remember what I talked about regular hexagons in that first area video on Tuesday night? Remember I talked about how regular hexagons means that they all have the same size, same length of each of their sides? Remember that? Well, if that's the case, then the perimeter is 60, so same kind of thing. 6 something plus something plus something plus something plus something plus something equals 60. And they're all the same somethings, right? So basically I need to divide 60 divided by 6 and see what the length of each of those sides is. Okay? So you're welcome. I just told you how to do that problem. All right, let's go down to these irregular polygons down here. Because these are going to require you to use your brain a little bit, all right? In these regular polygons, you see that there are quite a few measurements that are missing. Well, we're going to use our laws of rectangles and our gigantic brains to figure out what those measurements are. Okay, so I know that if I have a rectangle, let's just draw a rectangle right here. If I have a rectangle, it's not a perfect rectangle, but we're going to make it work. So, and I know that this is 12 meters up here. What do I know about down here? If this is a true rectangle, this also has to be 12 meters, right? And if I know that this is 5 meters over here, because of the laws of rectangles, what do I know has to be the length of this side over here? 5 meters. Right? Right, Miss Hargrove? Okay, so we're going to use that knowledge to look at these right here because these are technically rectangles with a chunk missing out somewhere, or 2 chunks missing, okay? So if I know that this length right here is 20 feet, well, I know that from here to here has to be 20 feet as well, right? Well, if this is 10, then I should only need 10 more to get from here to here. That's the kind of thinking that I'm wanting you to use right now. So I want you to think of this being your hole, okay, down here, from here to here, and this being your part, and you're trying to find this part right here, because if this is whatever it is, then this will also be that because of the laws of rectangles, right? Say it with me. Because of the laws of rectangles, okay? So let's work that out on this paper right here. So if I know that this from here to here is 20, that's technically my whole of this section, right? From here to here is 20. So I'm going to say that 20, my whole is 20, minus whatever this is. What's this part? 10, 20 minus 10 is going to equal my other part, which is this length right here. Well, what is 20 minus 10? 10. Okay, so that's what this up here will be. This is also 10 feet. Because that means that from here to here should also be 10 in order for this to equal 20, which should be equal to this right here because of the laws of rectangles, right? Okay, so I want you to use that same thought process to figure out what this length right here is. And you can use the fact that this right here is 28 feet. And so this length from this finger to this finger should be 28 feet. And we know that this is 9, so we need to figure out what this is to figure out what this is. I know that's kind of complicated. I just want you to practice, okay? You can ask for help if you need it. So I'll help you figure out one of these parts down here, and I'll help you figure out one over here, all right? So let's figure out what this one is right here. So if I know from here to here is 22 feet, well, I also know that from here to here should be 22 feet because of the laws of rectangles. So I know that I already have from here to here, which is 12. So I just need to find what this missing piece is. How long is it? So I'm going to say 22 minus this part right here, which is 12, should equal that missing piece. Well, what's 22 minus 12? Let's figure it out vertically. What's 2 minus 2? 0. What is 2 minus 1? 1. 10. Okay? So this missing piece right here should be 10. 10 feet. Okay? Let's work out this one over here. I want to figure out what this one is because this one's kind of complicated because we've got this hole over here and we have what this part is, and we can assume that this part is the same. So we have a hole in 2 parts and we don't have the last part. Oh my goodness gracious, what are we going to do about that? What are we going to do about that? Do you think maybe we could add these 2 parts and subtract it from the whole? And then that will tell us what this is right here? I think it would. Or we could say the whole minus this part, and then whatever that is minus this part will give us what's left. All right? Let's do that option. So we'll do 40, which is our whole, minus 7, which is the length of this part right here. What's 40 minus 7? Let's do it vertically. What's 0 minus 7? Can't do it. Okay, what's 4 becomes a, gotta borrow, 4 becomes a 3, 0 becomes a 10, 10 minus 7 is 3, and 3 minus nothing is 3. Okay, so now I just figured out what the length is from here all the way to here. So basically, I'm exactly where I was with the other problems, right? Now I have a part, and I have a hole, which is now 33 from here. So like, okay, so from right here to right here is 33 feet, okay? So now I just need to subtract 7 again, because that would be this part right here. So 33 minus 7. What's 3 minus 7? Can't do it. Okay, so got to borrow from this 3. 3 becomes a 2. This 3 becomes a 13. 13 minus 7 is 6. Right? So 2 minus something is 2. So now I know that this right here, this length, sorry, you can't see what I'm talking about. This length right here is 26. And I can double check that by saying so 7 plus 26 plus 7 should equal 40 because of the laws of rectangles, right? Okay, so we can double check that right now if we want to. Let's do 26. What's 7 plus 7? 14. We can just add all those together. What's 6 plus 4? 10. What's 2 plus 1? 3. 3 plus 1? 4. Did we get 40? Marvelous. Okay. So I'm going to give you a little hint as to how I think you should separate your irregular polygons here. All right. Probably separating this one right here. Remember, we draw a dotted line to separate it. I would separate this one along this line right here so that you have rectangle A and rectangle B. And I would separate this one like that. So you have rectangle A, rectangle B, or rectangle A, rectangle B. It doesn't matter which one you label A or B. You can separate them however you want to. That's just how I would separate them. And remember, to find the perimeter, you're going to have to add all the sides. You have to make sure that even though, like right here, it doesn't say 7, it's 7, right? You have to remember to add that in. And you'll have to find out whatever this is too. So you have to find those missing sides before you can find the perimeter, all right? Or the area in some cases. All right, guys, well, have fun with that one. I might just work it out right now because it looks like so much fun. All right, guys, have fun.